Hello, my name is Fabian Soto and this talk is entitled Subsampling of Cues in Associative Learning. In compound generalization, participants generalize knowledge acquired about certain combinations of stimuli to novel combinations of stimuli. A widely used paradigm is the summation test, where two cues, say A and B, are separately paired with an outcome and responding to a compound of the two stimuli, AB, is assessed during testing. A summation effect happens when the outcome expected for the compound is higher than the outcome learned for each stimulus by itself. The summation effect is anticipated by elemental models of associative learning, whereas configural models predict no summation effect. Contemporary models of associative learning assume that the similarity between the components A and B plays a key role on whether the level of summation observed is closer to the one predicted by elemental or configural theories. In a recent series of 6 experiments, however, we found no evidence for similarity affecting summation in human causal learning. Instead, we found a consistent summation effect regardless of similarity. In that work, the properties of the visual stimuli were such that participants could easily identify them on the screen during the test, regardless of manipulations of similarity. Perhaps an additional condition to obtain an effect of similarity on summation is that the components A and B must be difficult to identify. In our first experiment, participants were asked to play the role of an allergist whose goal was to judge the extent to which various drugs represented by different shapes caused allergy in a fictitious patient. We used a visual display that made stimuli difficult to identify. All stimuli consisted of 3 cues joined at a central point, and their position was randomly rotated so the spatial position did not provide information about cue identity. We manipulated similarity in 3 groups. Group intra included cues that varied only in shape. In group extra 1, A and B had different colors, black and gray, but the colors were shared with the non-target cues X and Y, one of them being black and the other gray. This means that although A and B can be easily distinguished, they are not easily distinguishable from the non-target cues. Finally, in group extra 2, A and B had different colors, black and gray, and they also differed in color with the non-target cues X and Y, which were light gray with black contours. If similarity between the relevant target cues influenced summation, we would expect higher summation in groups extra 1 and extra 2 than in group intra. If, in addition, similarity of the irrelevant non-target cues influenced summation, we would also expect higher summation in group extra 2 than in group extra 1. This figure shows the mean allergy rating to cues A, B, and AB. As expected, we observed a summation effect in group extra 2 and a lack of summation in group intra. However, there was no summation effect in group extra 1, which is unexpected by an associative analysis of summation. To confirm this, we performed simulations with Wagner's REM model of associative learning, which shows different levels of elemental versus configural stimulus processing by modification of a single parameter R. We assumed R equal to 0 for cues of different color, which would explain high summation observed in group extra 2. We simulated multiple values of R for cues with the same color to determine whether any value would reproduce the observed results. This figure shows the predicted associative value for test compound cues as a function of value of R. As you can see, no value of R could predict our results of summation in group extra 2 and no summation in both groups intra and extra 1. Across all values of R, the model predicts a large difference in the summation effect for groups extra 1 and intra, which was not observed in the data. If a simple associative analysis cannot explain these results, the question is what mechanism can. The key seems to be group extra 1, which showed an unexpected complete lack of summation. A key feature of the stimuli in this group is that a singleton target cue pops out from the display, which could lead to people subsampling only that cue and reporting its associated outcome value. Interestingly, such subsampling of cues could also explain the results of group intra, and thus the effect of similarity on summation. If that was the case, a visual search mechanism would underlie the effect in people rather than an effect on the representation of compounds. To test this hypothesis, in experiment 2 we used the same stimuli as group intra, but assigned different allergy magnitudes to cues A and B in different groups. Group intra was a replication of the same group from experiment 1. Group intra 2 involved 2 different outcome values, 10 points of allergy for QA and 8 points of allergy for QB. Subsampling of cues should lead participants to score the compound AB as producing either 8 or 10 points of allergy, indicating that they have responded in accord with the value of only one of the 2 single components. To the extent that one of the 2 cues is more salient, only one of those 2 scores should be more common than the other. So in experiment 3, we reversed which of the 2 stimuli was associated with 8 and 10 points of allergy to determine to what extent the more salient cue would drive allergy scores to be mostly 8 in one experiment and mostly 10 in the other. The results showed that ratings to ABX and ABY tracked the value of only one of the components, either B in experiment 2 or A in experiment 3. We formalized our hypothesized mechanism in an elemental visual search model, which assumes that when a stimulus display is presented, the participant samples a single cue or area in the display. Higher salience or associated value increases a cue's likelihood to be sampled. We also assume that when stimuli and compounds overlap spatially, they produce unique stimulus features in some areas of the display, which can also be sampled. This is represented by the Q labeled X in the figure. Once a stimulus is sampled, its associative value is updated depending on the observed outcome following a simple error-correcting rule. The model correctly predicts the pattern of results of experiments 2 and 3, and it can also reproduce the results for multiple experiments which have previously been put forward as evidence in favor of configural compound representation, such as the results obtained by Pierce and colleagues in 1997 in their differential summation experiment, and the results obtained by Pierce and Wilson in 1991, in which a first phase of training with A+ and AB- was followed by a second phase of training with B+. In summary, previous experiments have shown that summation in human causal learning is robust and independent of similarity. In 3 experiments, we showed that component similarity can reduce summation in human causal learning when the display makes Q identification difficult. We formalize a model that makes similar predictions as those of configural stimulus processing, but assuming elemental stimulus processing and subsampling of information during visual search. Thank you for your attention.